So good morning. Just a quick look at where I am with some of the components working on the 5200A. Let's get the morning coffee in. If you've seen the previous video, you would have noticed that the 5200A that I bought off eBay, the second one, still doesn't work. And so I contacted the sellers back, and I haven't heard from them yet. So I don't know what they're doing. I don't know what their plan is, but while I'm waiting to hear from them, I guess I'll go in and try and do some troubleshooting of it. So the first thing that I noticed was that on the actual oscillator card, as you walk through the troubleshooting guide, the card asks you to check some voltages, and those voltages looked pretty much okay. They look like they sat in spec. If you just bear with me, I'll see if I wrote them down. So here you can see this is the type of the table as you go through the oscillator assembly, and you can see I wrote down a bunch of measured a bunch of the values, and you know the actual values on the oscillator assembly itself, which I don't think I have handy. Yeah, which is the oscillator assembly itself. The actual values that I measured off the test points. If you look here, you can see where the various pads are. Let me see if I get some more light on that. Where the various pads are that show you some of the voltage of the rails. So the local regulation of this board seemed to be pretty reasonable, and so I was like, well, it's not going to be a power problem. But I decided to go back and just confirm that the rails were correct. And this is the power supply out of the 5200A, and it basically comes in 4 parts. It sits together like this. This is the big honking enormous linear transformer, and then these are 2 little cards that plug in, or daughter board cards that plug into the power supply motherboard. Now this card here is the power supply regulator assembly, and this guy here is just part of the power supply. But this regulator assembly is where the power supply goes through and sets all its individual voltages. So if I lay out the schematic here, and let's see if we can zoom in on that a little bit so that you can start to see basically what the thing is. We'll zoom in a bit more. Fundamentally, the power transformer comes in here, and you can see the little outline. That's the transformer assembly here, and then this is the power supply PCB over here. This is up here. You've got the power supply regulator PCB. You've got more of the power supply regulator PCB that apply those different voltages. Now the voltages that are coming out of here, if we zoom right in so you can get a good look at that, you'll see that basically we have a 30 volt power supply here. We have some plus or minus 15, plus or minus 5. We have our output low, which is basically the ground throughout the entire system for the control circuitry. And then in the top half here, you'll see, let me make sure that you saw this. There's a 30 volt, and then a bit below it you have 15 volts and the output low. And then on the top half here, this is where you're starting to get your very high voltages, and you can see that the plus or minus 190 volt, plus or minus 300 volts that you'll get. So this system isn't mucking around when it puts stuff on the cards. Like, where is it? Let's see if we get that under there. There you go. Like, danger, high voltage. They're very, very serious about the high voltages that you can get out of this. You can get plus or minus 300 volts, so you can get a 600 volt difference, you know, if you touch the wrong thing. So be very careful if you're playing with this type of stuff. So anyway, as I started looking through the power supplies, I noticed that the 30 volt rails were off, and they were off by 5 volts. So it seemed like the entire thing was shifted down by 5 volts. And so I started trying to find the problem, and you know, I couldn't find, let's go back in and look at the circuit quickly. Right, here is the 30 volt circuit. Let me get a pen out so I can point to it. And basically, from the linear power supply, you know, what we get is we come straight into a full bridge rectifier, couple of filter capacitors, and then we go into a set of transistors with some current limiting diodes here and here to actually control the output voltage, and that is all referenced to the plus 15 line that comes in here, right? So you know, you end up with your 30, and your output low, right? So when I measured it, you know, I had plus 25 minus 35 coming out of here, and the spec is plus 30 minus 30 plus or minus 1 volt. Now the 15 volt rail, which I'm referenced to, was bang on 15.00 volts, and so there really should have been nothing in here that drove it out. And so, you know, the initial culprits are the two electrolytics, so I took those out and measured them. They're good. They were, you know, 160 microfarads each. They had like 0.5, 0.4 ohm ESRs, so they seemed reasonable. The current limiting diodes I took out, I measured, they seemed reasonable. You know, these guys I took out and tested, and you know, I did notice that the HFE of Q9 here was getting very close to the bottom of its range. So, you know, it's from sort of 60 to like 120. It was very close to sort of 60, I think, or it might have been, so it might have been 100, 220. Anyway, that was very close to the bottom range. But still, it was just within spec. And so now then you've got the resistors, and all these resistors here were right. These two had clearly been replaced, and they were supposed to be plus or minus 5%, which on 20 ohms is plus or minus an ohm. They were well out of spec, 23 and 25. So what you can see though is if we have a look at the actual board, let me zoom back out again so you can get a better look at the board. You can see that I took the components off, and all that 30 volt componentry sits in here. And let me get a better pointer than that. It sits in here, and so I took it all off to get it. But you'll notice some. Let me see if I can angle it. You'll notice some interesting things come out here. First, you'll see that the two Q12 and Q9 really do run hot, and that's because they're basically these packages flapping in the breeze, just sitting up on there. And then immediately below them you'll see this is R16 and R21, and these two resistors here were those supposedly 20 ohm resistors, and they've been replaced previously, and you could see there's like a great mess of gunk on the back of the board here. Apparently there are some very low value resistors on this board that act more like fuses at times. You can see over here, if we get in, right in there, you can see that the board is scored and burnt. So clearly one of these two, R8 or R10 here, has blown up. And these are both 3.9 ohm resistors. So anyway, I took all those components out and I measured them, and they all seem to be, you know, within spec, with the exceptions of R16 and R21 and the HFE of Q9 here. So I'm going to go put them back in again, and then we'll see if we can get some voltage tests out of them. Okay, so let me zoom in a bit. You can see we have our components back in there. I found some 21 point, I don't have any 20 ohm resistors, so I found some matched 21.9 ohm, 22 ohm, 1% resistors, but they were 21.9 each. So hopefully it's not too sensitive to those values, and this will even up those rails. We got all the items soldered back in here, with our resistors in, and then on the main board over here we've got the caps in, and then CR6, the full bridge rectifier. So now that we're all soldered in, let's reassemble the board. This is the pretty empty chassis. This is about as zoomed out as I can get it. So the first thing that we want to do is put the power supply back on, and so this board will mount there. So let's start reassembling the power supply board. So this is the main power supply motherboard, and it will sit basically in here, and then the transformer board plugs in here and the daughter boards plug in here. So let's just go and start putting those guys back together. Okay, so now let's get these little daughter boards back in. Okay. So this is actually a pretty ingenious, let me make sure this is in shot. It's actually a pretty ingenious little idea from them to hold the daughter cards in. Plus gives you an easy tool to push them in to do it. When you, let me find the little lid. Here you go. When you put the cover back on, it has a little spacer in here that will keep this handle over here, which helps stop those cards popping out. But the little handle gives you enough leverage that you can line the card up just like this. These little nubs here help get it into the slot, and then once you're all sort of lined up, you can just grab this item here, push it across, and it'll seat the card for you. So there you go. We now have our item set in. Let me set up again and see what the 30-volt rails look like. Okay, so I have it all plugged back in. Let's hook up. Let's hook up a little bit. So we want to hook up to test point 5 here. It should be that guy there, so that should give me voltage. Alright, and then I have these two mini grabbers, because the 30 volts, for whatever reason, they didn't put on a rail anywhere, on a test point. So let's see if the magic smokes come out. I'm going to turn it on. Nope, no smoke. Alright, so I'm getting plus 30. Nice, which I wasn't getting before. I'm getting minus 6. I might have that on the wrong test point. Let me go change that. Okay, so yes, I did in fact have it hooked to the wrong side of R22. So that's going to make a difference. So let's turn the power back on, and you're going to have to trust me because I can't get my multimeter into the shot here. And now I get 30.25 volts, and I'm getting 30.018 volts. So I don't know if it was these little resistors that that I'd had in there previously, that somebody else had in there, that were wildly out of they were well out of spec, or if it was a dry joint or something. But now that I've gone back in and I've replaced those resistors, I'm now getting good plus or minus 30 rails. Let me continue on, and we'll see something else happen in a future video. Catch you later. Bye.